Good morning and happy Wednesday. It's September 6th, and I'm planning on doing LeetCode daily challenge for today. Share my screen and we'll start jamming here. Okay, so problems. 6th. Split link placed into parts. Five different parts, 3 different parts. The biggest chunk is the first chunk, it looks like. I wonder if I solved this one all right. Nope, doesn't look like I've solved it yet. So this is brand new. Okay, that's cool. Let's do this in Python 3 first. So it is 5:53 in the AM. Game plan. So we can first traverse the list to know the size and be the cardinality of the list. Each chunk size and divided by k. So here k is 5 and n is 3. So example 1 equals 3, k equals 5. So we need to take the ceiling of that then until we run out of n's, right? Or stealing this guy. Oops. Screenshot here. Oops. Okay, go. And this guy is 10 chunks of 3. So this is example 1 for this guy. Oops. And example 2. Example 2. N equals 10. K equals 3. So the ceiling n divided by k is 4. So that's not quite right. So n is up to 1,000, k is up to 50. So k is not that big compared to n. I wonder, we can do this from right to left instead of left to right. Let's see. So question, is it helpful to fill in from right to left rather than left to right? And I think so, right? So if we can do, instead of the ceiling, I'll just do the floor, right? 10 divided by 3 is 3. And then whenever we have extras, we'll have to add them on to. And so here the floor, or 3 divided by 5 is 0. So we have to do 0. So this is a special case where k is greater than n. So let's just treat this as a special case then. A special case where n is less than k. So if n is less than k, it's all singles, right? The upshot is, oops, upshot. We had singles, right? the singles. Otherwise, we'll take the floor, this guy, fill it in from right to left, and then there's extra. If there's extra there, what if this thing was 11? Right, so if it's 11 instead of 10, question. What if n equals 11 instead of 10? Right, then we'd have 11, oops, n equals 11, equals 3. The floor, 11 divided by 3, oops, 11 divided by 3, that equals still 3. Right, so there's some additional logic in that we need to have 3 and then 4 and then 4. Wait, let's do this. What if we had, oh, okay, so I think it makes sense. Okay, now let's say n equals 8 and then k equals 2. So the floor of 8 by 2 would then equal 4. Score equals 1. The floor of 1 is 4. These do we have to choose from? Oh, actually, this works too. Okay. So that, I just kind of stepping through this actually should work for this special use case as well. Right, so we know we want 5 slots, right? 1, 2, 3, 4, 5. So if we're going to fill it from right to left, oops, right to left, have in equals 3, oops, equals 5. So then make the floor of 3 divided by 5, oops, 0, right? So we stick nothing in this one. Similarly, we'd have the floor, so 3 to choose from, and then we have 4 slots. After that, 0. So this guy would also be 0. The second one from the right. Oops, wait, hold on. 4 divided by 3 divided by 4. Right, and then after that, we have floor 3 divided by 3. And 2 divided by 2. And floor 1 divided by 1. Right, as we decrement in. Okay, so I think that makes sense then. So we can probably do this recursively, right? So if we recursively go, as a recursive stack on lines, it'll be in reverse. I wonder if that's too complicated there. Let's see, there's only 1,000 of these things. So maybe we'll stick it into a single array. So yeah, here's the game plan, right? Reverse the list and then stick this in an array A, right? Then partition the array A based on this logic down here. Right, so that's the game plan, 553 to 601. 601. That took about 8 minutes for the game plan. And let's do the implementation. Space down here. Okay, so here's our array. Then node equals head. Just do this. We only need to traverse the list once, right? File node. Next, traverse it in a dot and node dot value. So stick that in the array. N is the cardinal inventory A. I'll fill it in from right to left. So there goes this. And just make it a deck. How about? Wait, and then oh yeah, we do want this to be a deck then, right? We can push it from right to left and push from the one to the left and go to the right. Okay, and then turn the answer to the list. Back into the list. Or we can just reverse the answer too, right? First answer. Okay, so while n, we'll take a chunk of k, take equals the floor of n divided by k, n minus equals what we can take. It's an atomic operation. Okay, so we'll call this a row we can take. It'll be that last chunks. Well, you take something, take perhaps this four, range, we'll take, let's do this loop, take many times, row dot end, a dot pop. So it'll be in reverse, and it's going to append, row, reverse row, first answer. Okay, so the row might be empty, right? If n divided by k is 0. Uh-oh, if n divided by k is 0. Wait, then we don't take anything. Okay, so if not take, let's take, if take, otherwise we'll just subtract 1. Wait, no, with subtract from k, right? N minus equals take, and then k minus equals 1. Wait, no, I'm getting confused. Hold on. We don't want to reduce k, right? We want to reduce n by what we take, but here we don't take anything. We take nothing. So k is reduced. Okay, yeah, so k is reduced if we take nothing. If not take k minus equals 1. K minus equals 1 if not take 0. Do that. Okay. Let's the list, put it into our array. N is the Cardinalian for array A. The answer is formulated in reverse from right to left. And so I pop off of A onto each row, which we append onto the answer. It should not be a copy of row, it should be, or yeah, this should be a deep copy of row, right? So this is reversed here. and then reverse the entire answer. Okay, I think that works. Let's see what happens. 607. Uh-oh. What happened here? Oh, it's supposed to be a list node, not the values themselves. Oh crap, okay. You don't append, oh, not just the value, just the node itself, I guess, right? Node itself. Okay. Oops. Uh-oh. Oh, next. What's this? Well, are they supposed to still be connected? Like, what is the next pointer for this guy, right? It's like a list of optional list nodes. Oh, okay, so maybe this one only has one, 5, and 8, maybe? And then you set the next pointer to null. This is not really well written. Yeah, so how do you, it doesn't really explain. It's a list. Okay, yeah, I have to look at this, right? Okay, and it should say that these are individual linked lists. So it's poorly worded. Okay, I mean that takes some additional time too. Some poorly worded, ambiguous questions, right? Okay, so we only want the first of the row then. Row sub 0, it will be last, right? Since it's backwards. Since it's backwards, row sub 0, that next is none, right? Truncate the linked list, only append. So pop 10, pop 9, pop 8. It will be at the end of the row. 10 will be at the beginning of the row. Okay, something like that then. So if length of the row otherwise hands not append to none, it's just an optional linked list. Okay, let's see what happens here. I think that looks good. Whoa. What? We don't take anything in this empty, so those look good, but is there an empty between these two? I wonder if it's not expecting this. Oops. Strange. Hmm. Okay, well, if I don't set the next, then it's still a linked list. So I want it just to be that gonna be why is there an extra none here? And none between the 3 and the 2. Uh, let's do some prints. All right, well, here, I'm debugging, right? Keep checking my time. Indentation was complete, but it's like debugging. Debugging. Keep track of init implementation. Check where my time's going here. It's been 20 minutes. The one I misread the problem statement. I thought it was an array. Here it's a list of optionals. So it's a list of linked lists, which we have to terminate, right, as we partition it. What the heck's going on here there? In okay, okay. Take, taken, right? Take. Okay, let's see what's going on here. Debug prints. Okay, I take nothing. Let me take the 3. Oh, we still need to reduce K. This. Okay. Okay, so. Oh, if it exceeds K, nothing, take nothing. Here we take 1. This 3 K is 3. Or N is equal to K. Factored by 1, right? Uh-oh. N is less than K. N is less than K. It would reduce K by 1 here. Reduce K by 1 here. If it is less than K, we're not taking anything anyway. Minus equals 1. K is less than or equals to 1. 0 or 1, reduce it by 1. Okay. And then this guy, oh, come on. Whoa. Oh, wow. This is way off. Okay. Well, actually, the first one's right. Oh, man. Okay. So maybe I should handle the corner case. like where I said that it's going to do this. I don't know if I can do this generically or not. Where it works with both. I want this also to work for 3 divided by 11 as well, or 11 divided by 3, right? So for 11, we'd have 2 chunks of 4. Take 3, so it looks right. N equals 7, K equals 3, that's not right. So subtract N by K, right? Just subtracting it. N by K. Otherwise, subtract K by 1. And 7 left. 2 to choose from. You can just always subtract K and subtract N by K. Let's see here. I mean, this is correct for the first, oops, for a Q1, right? Not the Q2. What if we change our game plan there, right? So if A is less than N, let's come up with a game plan first, right? Rather than just kind of coding it and hoping, right? So I was onto something here. Reducing K by 1 each time. Reducing K by 1 each time. 4, 3. It should be reduced by what we take. Not by K, right? It should be reduced by what we take. Take K is always the student's K always minus equals 1. Always reduce the number of parts we need K by 1. So it's 5. We take 0, then it's 4. We take 0, then it's 3. We take 1. Reducing by 1. We take 2. We take. Let's make sure we didn't break this guy. Let's just do this. Minus equals 1 always. And then this guy, K minus equals 1 always. Okay, that was good. Okay, I think this works. So let's try this with 11. We have 2 chunks of 4, followed by 1 chunk of 3. Okay, that looks good then, right? Okay. Let's get rid of my prints, and then this looks good. Let's see what happens. 621. Oh. Oops. Submit. Answer. This one bug. Oops. The corner case of empty. So I did miss that, right? There could be 0 nodes. Oops. This guy. Okay. So N is 0, K is 3. If not K. Otherwise, if K exists and N does not, Then we'll just do none times k. Oops, none times k. Okay. That's good. Let's make sure we don't have any regressions. Okay. Big money, no whammies. Yay. Okay. That works. And that was accepted at 6:22. 6:22 a.m. So from 5:53 to 6:22, that took what, 29 minutes? It's 29 minutes, right? Yeah, it's okay. This one was kind of tricky, and then I misread it, and then yeah, it's just kind of weird. Filling it from right to left. It's just a tricky question. It's cool. And whatever. I'll vote it. And then okay, 6:23. So yeah, I might as well do this in the other languages here real quick. And maybe see if I can clean this up a little bit. Each row. It's a decent solution. We'll just code it in the other languages and then see if there's some optimizations we can do. Few solutions. Oops. Solutions. When JavaScript. 3. Rust. If it exists, it C++. Okay, let's see. Does this one have Rust? Yeah, it does. Okay. So it has Rust. Let's do C++ maxed out. All right, 6:24 in the AM. Using nodes equals node pointer. Using nodes, nodes equals a vector node. And so we'll turn nodes. Node. We only need to traverse the list once. Right, so while node nodes a dot push back node those nodes next answer. Oops. For the interior, if k, right, k does not exist. No. Well, if k does exist, then one array of known nodes of size k called empty nodes. Otherwise, the answer. Okay. That size. And it's important that n is an uns or it's a sign value, right? We don't want to be unsigned, otherwise if we go back to 0 or less, then it'll be a giant positive number. Right, we want to go negative. So cast the size t, which is an unsigned integer, into a signed integer explicitly. Okay. And actually, this is probably it's a little bit more of a boost, but this is maybe one we'll probably do in like production code as a static cast to an integer. Okay. But that's for bonus, right? Let's just do this. Okay. Nice for the loop. take is in the verb K, for that. Take one, and go with that K. Take whatever it is, right? Then n is subtracted by what we take. A is subtracted. Second right each time. So this should be an integer as well. What it is. There it is. We'll live forever. It's that sign here. Okay, so what we take then row dot push back a dot back a dot pop back. Right, so push those there, and then if take wait, no. If length of the row, right? Answer, push back. I actually want to return nodes, this guy reverse. Okay, and we have to explicitly say nodes because initializer lists are not allowed with the ternary operator. So the answer, push back, row dot back, and then row sub 0 in front. So the next is none. Otherwise, if there is no row size, answer, push back, just a null. So here will be the head, which is pushed in reverse. And so the 8 in the front will be the last of the partition, which will be this guy. It's to null. Okay, I think that's good. Let's see what happens. Oh, it doesn't look right. Well, and I'm subtracting. Oops. Okay. Small bug. 6:30 right now. Okay. Let's submit it, see what happens. 6:30. Okay, cool. 6:30 a.m. is about 6 minutes. Oops, 6 minutes for the implementation in C++, which is accepted. Yay. Okay, so that's cool. Boom. Let's do this in JavaScript. 6:31 in the AM. Actually, let me look at this. Yeah, okay. Let's do this guy. Okay, this is the node. So our kth value. The answer is what we formulate in reverse. K exists, then we'll return an array of size K filled with nulls. Otherwise, you return the answer if K does not exist, right? So that's for the corner case, so the empty list node, but K exists. Okay, and then while node equals node next, and then A, which is our array, which will store these things temporarily. Push, oops, push node. It's N is the Cardinality array that we formulated, right? while in, I need to partition this thing. Row is this guy. Let's take those floor into K. K into K minus minus. Clean that up in C++ as well, right? K minus minus. Yeah, I don't know. I mean, that's weird. Whatever. It is kind of ugly. Let's just do this. Okay, afterwards. Yeah. In minus equals take. This to be like an atomic operation, right? This is what we take, and then based on what we take, then N and K are reduced. Okay, and then while take and push A dot pop. If row has a length, then the answer push so row dot length. That's one, like the right left side is pushed. Oops, zero, that next is none. Otherwise, we'll push none into the answer. Okay, let's see what happens here. 631, 634. Uh-oh. Oh, we need to return this in reverse. Reverse. Looks good. 631, 634. All right, cool. This is more where I want to be, right? The as a potential contestant, 3 minutes for the implementation in JavaScript, which is accepted. Yay. Okay. This one's cool. Stick that there. Okay, we'll do Kotlin and then Rust. I'm really glad to see Rust. It's kind of bittersweet in that Rust is difficult. Rust really gives me a hard time still. And then I can't change the volume of this thing. There it goes head. Wow, node is not going no. Oops. Nodes next. And then create an array. A is a mutable list. It's a mutable list of, let's see, data and node, right? And is the cardinality input array A. And then while n exceeds 0, if a exceeds 0, then return an array of wait, array size k filled with otherwise return answer reversed. Okay, and then row is a mutable, mutable list of standard orders. Take is the floor of n divided by k. N subtracted by what we take, and then k is decremented by 1. Now, take exceeds 0. Add a remove last one. or not. If that size this answer dot add null answer dot add row dot last row sub 0 so next equals none. Okay, oops, I didn't keep track of time. We're at 6:38 right now. Started at 6, somewhere between 6:38 and 6:34. A val cannot be reassigned. Oh, crap. Is this guy. Arguments. Let's see. Kotlin remove last value from list. Okay, this is creepy. Siri is just like listening to me. Don't turn it off. Okay. Holy cow. Okay, remove last. Yeah. I guess this is what I wanted, right? Remove last. Usage. Remove last. Oh, remove last, and that's it. Resolved. Oh, great answer. Answer is a mutable list of list nodes. And then we will answer two typed array. First. Actually, I want to reverse it and then change it to two typed array, right? List nodes from a mutable list. Big money, no whammies. Yay, okay, that was good. Let's see what happens. 6:38, 6:40. Oops, 6:40 a.m. Okay, cool. That's I don't know how many minutes it took. Because I didn't really start at 6:38, right? Push more minutes for the implementation. Sampling implementation in Kotlin, which is accepted. Yeah. Okay, we grab this guy, stick it here. Oops. All right. Decent solutions. We'll implement this one later. Do implement me. Whatever. That's good enough for now. And so, oops, I need to write a little description. Verse and verse the linked list storing nodes in an array A. Find cardinality. And cardinality of the nodes in. Right, then take chunks of K nodes per partition. Partition. Formulate the answer from right to left. in return the reversed answer. Okay, that sounds good. All right. I'll catch y'all later.